Now let's continue our factoring of trinomials and now look at what we do when we have a leading coefficient that is not a 1. So we're still looking for a product and sum, but this time the product is A times C. The sum is still B. And just like we did before, we're going to go ahead and split our B term into two separate terms using that pair of numbers that we found, so that we have 4 terms and we can factor by grouping. So what we did as our first example in the previous lesson, without the shortcut, is the formal process that we'll be doing for all trinomials, especially when we have a leading coefficient. And even if you consider our previous examples, we're still doing A times C. The only difference is that 1 times 16 is still 16. And so technically we're factoring in the same way, we just have a shortcut when A is equal to 1. So let's go ahead and take a look at our first example. We want to find a product of A times C. In this case, A is 2 and C is 15. And then we have a sum that we need of 11. So 2 times 15 and 11. So 2 times 15 gives us 30. So let's look at our factor pairs of 30. Second graph to look at our table, and we want a sum of positive 11. 31, negative 17, negative 13, there's our 11. So the two numbers we need to use are 5 and 6. So we take our middle term, and we want to split it into 2. So that way we have 4 terms in our polynomial. The order of those 2 terms in the middle usually doesn't matter, but I tried to group them with some easy coefficients that are in common to make the factor by grouping a little bit simpler. And I saw that 2 has a common factor with 6 and not 5, but 5 also has a common factor of 15, so this seems like a good, easy grouping. So we factor by grouping 2x, x plus 3, plus 5, x plus 3. We have our matching binomial pairs, x plus 3, leaving us with 2x plus 5. We could double check our answer by multiplying it out. X plus 3 and 2x plus 5, 2x squared plus 5x plus 6x plus 15. Combine like terms, and since we got our original polynomial, we know it worked. All right, let's do it again. I want a product of 3 times negative 4, which is negative 12, and a sum of negative 1. Well, that's pretty easy because I can see that 3 and negative 4 will give me the sum of negative 1. So I can use the numbers 3 and negative 4. 3x squared plus 3x minus 4x minus 4. Factor by grouping. 3x, x plus 1, minus 4, x plus 1. 3x minus 4, x plus 1. Here we see that we have x and y. We have a GCF. We also have a numerical part of our GCF, which is a 2. So let's go ahead and factor that out. With the GCF of 2xy, we end up with 2xy times 6x squared minus 11x plus 4. Then we want to go ahead and look for our product and sum. A product of 6 times 4, which is 24, and a sum of 11. So we want 24, and let's not forget it needs to be a negative 11. Well, I can look here, negative 3 and negative 8 give me negative 11. So we can go ahead and rewrite our trinomial to be minus 3x minus 8x plus 4. And don't forget our GCF. Factor by grouping. 2x minus 1 is 4, 2x minus 1. Don't forget the GCF. And then since we've got our matching binomial pairs, we have 2x minus 1, and we're left with 3x minus 4. Here we take a look, 16, 24, 9, there's no GCF. X squared, xy, and y squared, again, no GCF. But it's okay, we can still do our product and sum. A product of 16 times 9 and a sum of 24. 16 times 9 is 144. And so when we look at 144 divided by x, and we want a sum of 24, we'll have to go into the positives, and we see that we get 12 and 12. So we're going to be using 12 and 12. 16x squared plus 12xy plus 12xy plus 9y squared. Factor by grouping. 4x gives us 4x plus 3y plus 3y, 4x plus 3y. We end up with 4x plus 3y with our common binomial, and then we're also left with 4x plus 3y, giving us 4x plus 3y squared. For e, no common factor, so we want a product of 6 times 6, which is 36, and a sum of 13. 36 divided by x, sum of 13, we get 4 and 9. 6x squared plus 4x plus 9x plus 6. Factor by grouping. We've got our matching binomial pair. 3x plus 2. 2x plus 3 is what's left. And we're factored again. F, we want a product of 18 and negative 2, negative 36. And we want a sum of negative 9. So we'll change this to negative 36 divided by x. And we want to look for a sum that gives us negative 9. We've got that with 3 and negative 12. 18x squared minus 12x plus 3x minus 2. We can factor out 6x, leaving us with 3x minus 2. This is already 3x minus 2, so we just factor out a positive 1 with our matching binomial pair as one of our factors, and 6x plus 1 as the other factor. Now here, we've got a special process that we're going to do. It's called factor by grouping. And we'll come back to that in the next video. Factor by substitution, which we'll come back to in the next video.